Good morning, my dear students. My name is Twayna. I'm currently available at the Hamlet Tuition Center, Brahmatul, Kathmandu. If you want to contact me, my contact number is 9849135739. I'm also available currently at Kumudini Secondary School, Kalimati, Kathmandu. My dear students of grade 9, this is your science class, and in your science class we have been studying about electricity and magnetism. In our previous class we discussed about introduction to electricity. What is electricity? Okay, and then what is electric charge, electric current, and potential difference. In today's class we are going to discuss about Ohm's law. Okay, Ohm's law, which gives you the relationship between amount of electric current and potential difference. Okay, I want to begin with this cartoon which I found somewhere over internet. Okay, this is very impressive. See, this is the conductor wire, okay, which indicates a path of electrons, and this is amount of electric current. The electric current, it has to pass through the wire, okay, and who pushes electric current to move through wire? It is potential difference. Okay, potential difference pushes the electric current to move through the wire. And ohm is, it is resistance, isn't it? What resistance does? Resistance makes it harder for electric current to pass through. Okay, and stronger the potential is, more chance is the electric current to flow through, pass through it. Okay, if the potential is stronger, then there is high chance that electric current will pass through this resistance. Okay, but if the resistance is weak, then you don't need strong potential at all, isn't it? Well, this cartoon shows a lot. Okay, I like this cartoon very much. This cartoon shows a lot, isn't it? Do you get it or not? Okay, so it basically tells you that ampere or electric current is the number of electrons passing through the conducting wire. And what causes electrons or electric current to flow through the wire? It is potential. Because of potential difference, electrons would flow. And what opposes the flow of electrons? It is resistance. Okay, so if a conductor wire have very high resistance, then you need to provide high potential. Yes, you need to provide high potential for current to flow. But if the wire has very low resistance, then you can make the current flow with small voltage as well. Understood? So what this diagram specifically depicts is what amount of electric current would flow through the conductor is directly proportional to potential difference. Okay, what amount of electric current would flow through the conductor is directly proportional or is directly dependent to potential difference. If there is more potential, then you can see that more current would flow. If there is less potential, then you can see less current would flow. And what is the restricting factor here? That is resistance. Understood this diagram? Okay, if you do understand this diagram, then let us go through the statement. Ohm's law was proposed by George Simon Ohm, a German physicist. Okay, from his name itself, the law is said Ohm's law, and the statement is very simple. The current flowing, the current flowing through the conducting wire is directly proportional to the potential difference across its two ends at constant temperature. If the temperature is constant, because we know that resistance depend on temperature as well. Okay, So at constant temperature, what amount of current will flow through the wire or conductor depends on potential difference if we keep resistance constant. Okay, so resistance or ohm is actually the property of conducting wire itself. You cannot change this. You cannot change this. Okay, that is why the relationship is established between potential difference and electric current. Okay, the current flowing through the conducting wire is directly proportional to the potential difference across its two ends at a constant temperature. So mathematically it would state I is proportional to V. This is not U, this is V. I means electric current, V means potential difference. Okay, I means electric current, V means potential difference. Okay, so you know that in physics this proportionality sign does not mean equals to. Proportionality sign does not means equals to. It only means that if V increases, I also increases. If V increases, I also increases. But what factor? If V increases by 2 times, by how many times will I increase? Well, that is not known. Okay, proportionality sign does not tell us that. So there is a factor by which I should be or V should be multiplied so that it would be equals to I. There is a factor by which V should be multiplied so that it would be equals to I. Okay, and such factor is known as a constant, proportionality constant, and in this case the proportionality constant is 1 by R. Okay, 1 by R, where R is resistance. Okay, R is resistance, and the proportionality constant in this case is the inverse of resistance. Okay, why is it used inverse? Because according to this diagram, if R increases, the current flow decreases. See, if R increases, current flow decreases. So there is inverse relationship between I and R. There is inverse relationship between I and R. Therefore, the proportionality constant is not taken as R, but it is taken as 1 upon R. Okay? Yes. So I equals to 1 upon R into V. So by cross multiplying you get the R will be cross multiplied to I, isn't it? So you get V equals to I into R. And this formula is also very easy to remember. VIR भीर भीर भीरबाट खस्नु हैन. Okay, VIR भीर. Any confusion? Now the SI unit of resistance is ohm. Okay, R is known as resistance and SI unit of R is ohm. OHM, ohm. Once again, after the name of George Simon Ohm. Okay, if you happen to be very much accomplished scientist, then in your honor also name of units or name of physical terms can be dedicated. Okay, just like that, the SI unit of resistance is also dedicated after George Simon Ohm. Okay, it is ohm, and the symbol is omega. This symbol is called omega. Okay, now how do you define 1 ohm resistance? See here, in what case you get R equals to 1? If the value of V and I both are 1. If the value of V and I both are 1, then you get the value of R to be 1. That means 1 voltage potential, 1 ampere current. Okay, if by applying 1 voltage potential, we need to manipulate voltage. Yes, if by applying 1 voltage potential, then 1 ampere current flows, then the resistance is known as 1 ohm. Okay, so by applying 1 voltage potential, how much current will flow through the circuit? Okay, flow through the conductor. That determines its resistance. If by applying 1 voltage current only 1 ampere current flows, then resistance is 1 ohm. Or if 0.5 ampere current flows, then resistance is 2 ohm. See, resistance and ohm or resistance and current has inverse relation. Okay, if by applying 1 voltage current 2 ampere current flows, then resistance is 0.5, like that. Any confusion up here? Okay, so you can define 1 ohm resistance as when 1 ampere current is flowing through the circuit. When 1 ampere current is flowing through the circuit, if it has to perform 1 joule of work, that means 1 voltage potential, isn't it? 1 voltage potential is defined as if 1 joule of work is done by passing 1 coulomb charge, then that is 1 voltage. Yes, it is called 1 ohm resistance. Okay, I guess this will be little bit controversial. Okay, let us not use this definition, because here here it says 1 joule of work. 1 voltage actually relates to 1 coulomb charge, not to 1 ampere current. So let us not use this. Okay, just erase this. Okay, use the second one. When current is passed through a conducting wire at 1 volt potential difference. See, when current is passed through a conducting wire at 1 volt potential difference, if 1 ampere current flows through it, the resistance is called 1 ohm. Done? Okay, if you have no confusion in Ohm's law, let us go to the next topic, that is resistance. Okay, well, you pretty much have already understood what resistance is. Resistance is a factor or property of conductor. Here in this cartoon we discuss it as resistance is the factor or property of the conductor which tries to stop or which tries to oppose the flow of current through it. Okay, the factor which does not let the current to pass through it, that is resistance, isn't it? So resistance is defined as a property of conductor due to which it tends to oppose the flow of electricity and it causes loss of electrical energy into heat energy. If the electrical energy cannot pass through, then it will be converted to heat energy. Okay, and SI unit of resistance is ohm, which is indicated by omega sign. Yes, now the relationship between resistance and the nature of material. Okay, nature of material based on resistance. Okay, nature of material based on resistance. You can see there are altogether 3 types of materials. Okay, there are 3 types of materials based on resistance. Okay, first of all, those substances which have very low resistance. Very low resistance means they would allow maximum amount of current to flow. They are known as good conductor. Okay, they would allow maximum number of electrons or electricity to flow. They are referred as good conductors. Some example: silver, copper, gold, etc., which are also used for making wires. Okay, and the second one, the substance which have comparatively high resistance. The substance which have high resistance but still not so high that they would completely block the electricity. Okay, they have high resistance means they block maximum amount of electric current. Okay, they oppose maximum amount of electric current but not 100%. They allow some amount of electric current to pass through. Okay, such materials are known as heating elements or resistors or even semiconductors. Okay, they are known as semiconductors, okay, which are used for making heating elements or resistors. Some examples are nichrome. Nichrome is an alloy of nickel and chromium, and manganese alloy, that is manganese is an alloy of manganese and nickel. Okay, and similarly the substance which have extremely high resistance, Extremely high resistance means they will not allow any amount of current to pass through them. Okay, they will not allow any amount of current to pass through them. They are called insulators. Okay, insulators. The substances which have extremely high resistance are referred as insulators. Any confusion? So based on resistance, there are three nature of materials. Yes, good conductors, semiconductors, and insulators. Okay, here resistance are called called as better than called as, let's write referred as semiconductors, and are used as heating element or resistors. Well, any confusion up here? So what did we study until now? We studied about Ohm's law. Ohm's law dictates the relationship between amount of electric current and potential difference, keeping the resistance constant, because in a particular wire the resistance is definitely constant, isn't it? Resistance is property of conducting wire. So keeping the resistance constant, it gives a relationship between potential difference and electric current. So that means I is proportional to V, and by keeping the constant term, proportionality constant, that is 1 upon R. Okay, in general the proportionality constant is not used as a fraction, but here we are using it as fraction because this proportionality constant or resistance has inverse relationship with electric current. Resistance increases, electric current decreases. That's why I equals to 1 upon R V, and by cross multiplying you get V equals to I into R. Yes. Okay, so this R, it means resistance, and then next we defined resistance. Yes, resistance is defined as the property of conductor due to which it tends to oppose the flow of electricity, and it causes loss of electrical energy into heat energy. Any confusion up here? Okay, if you do not have any confusion with resistance, then let us go to the factors that affect resistance of conductors. Okay, what affects resistance? We already discussed that resistance is the property of conductor, isn't it? Resistance is the property of conductor. Now, what properties of conductor actually affect the resistance? What properties of conductor affect the resistance? Let us discuss that now. Okay, there are altogether five factors that affect resistance. Okay, there are 5 factors that affect resistance. The first one is length of wire. Just think that you are in a marathon. Okay, you are in a marathon. Yes, and at the beginning you might run very fast with high speed, but as you keep on running, your stamina will keep on losing. Yes, and then your speed will keep on decreasing, isn't it? Longer you have to run, more speed you will lose, or more energy you will lose. The same rule goes to electrons as well. Okay, current means flowing of electron. Yes, so longer the electrons have to travel, more the energy they will lose. Longer the electrons have to travel, more the energy they will lose. That is why resistance increases with increase in length of wire. So resistance is directly proportional to the length of wire. That means longer wire has more resistance. I have given you 3 sentences here. You can write any one. Okay, you don't actually need to write all 3. You can write any one. Okay, and next one is area of cross section of wire. Okay, area of cross section definitely means thickness of wire, how thick the wire is. If the wire is thick, then it will have more cross section area, more cross sectional area. If the wire is thin, then it will have less cross sectional area. Okay, now you can compare this to your being marathon runner. Suppose you are running in a marathon, there are 10,000 participants. Okay, so in one case you get to run in very wide road. In another case you get to run in very narrow road. In which case will you be able to run fast? Definitely in a wide road you will be able to run fast, but in narrow road you might have to compromise with your speed because there would be lot of crowding. In narrow road there would be lot of crowding. Okay, so thickness is inversely proportional to resistance. That means if thickness increases, resistance decreases. If thickness decreases, resistance increases. Okay, so resistance decreases with the increase in thickness of wire. So resistance is inversely proportional to thickness of wire. That is, thicker wire has less resistance. Understand this or not? Okay, next one is temperature. Okay, resistance increases with temperature of wire. Okay, once again you can consider yourself to be marathon runner. Okay, I'm frequently telling you to consider marathon runner, but are you being able to picture it or not? If not, I can get a picture so that you can picture it. Let me see. Okay, you consider yourself to be a marathon. Okay, think of a cool day. Think of a cool day when you have to run, and think of a very hot, scorching hot day when you have to run. In which case will you be more resilient? In which case will you be running more actively? Is it in hot day or cold day? Definitely in cold day. In cold day you will run faster, but in hot day you will get tired too easily, isn't it? That means your speed is inversely proportional to temperature. Yes, temperature increases, your speed decreases. That means resistance increases. With increase in temperature, resistance increases. So that's the same case here also. Temperature, resistance increases with temperature of wire. So resistance is directly proportional to the temperature of wire. Understood? You understand the relationship with length, you understand the relationship with cross-sectional area, and you understand the relationship with temperature. Yes? Now you can relate them with the marathon, the case of marathon as well. You are marathon runner. Okay? If the road is very long, if you have to run for very long distance, then you will lose your stamina, isn't it? And losing stamina means increasing resistance. Or if you have to run through very narrow lane, narrow path, then also you will lose your speed. That means resistance increases. Now if the temperature of day is very hot, once again you will lose your speed. Just think, each one of them are electrons, and the path is the wire. Okay. Okay, now the fourth factor that affects resistance is nature of material. Okay, resistance depends on specific nature of material, which is known as resistivity. Well, some materials simply resist more than some materials, whereas some materials allow currents to flow through it. Okay, the materials which have more free electron in themselves, they will allow electron to pass through. Okay, the material which have less electrons, let's say the materials which have less electron will resist flow of electrons because they tend to absorb electron. Just think of it, you are carrying a briefcase. Suppose you are carrying a briefcase full of money. Okay, like a man carrying briefcase. Okay, suppose that you are carrying a briefcase which is full of money. Okay, and you have to go somewhere, and you can take two paths. One of the path goes through the person who are very poor, one of the path goes through the persons who already have more money. Okay, then which way would be safe for him? If we take the path where people don't have money, then they will tend to steal his money. Okay, even if they don't tend to steal, they beg from him, and he is obliged to give them something, some money. He is obliged, he must give some money if someone asks him, not if all, he must give some money. Then he keeps on giving or donating money to those whoever comfort him. Then at the end of the road, very little money will remain in his bag, isn't it? But if he goes through the path where people already have more money than he has, then no one will come to ask for money to him, and he can get all the money through the path, isn't it? Similarly, here also, what kind of material the electrons are passing through? If the material already has sufficient electrons, then they don't absorb electrons from electricity, okay, and they will have less resistance. But if the electricity is passing through a material which have less number of electrons, then the material itself absorb the electrons from electricity. बुझे कि बुझेन? यदि इलेक्ट्रोन अलरेडी धेरै छ मटेरियलमा भने उसले इलेक्ट्रिसिटीलाई एब्जर्ब गर्दैन, तर मटेरियलमा इलेक्ट्रोन्स थोरै छ, नेचुरली इलेक्ट्रोन्स थोरै छ भने, जस्तै नन मेटल्समा हुन्छ है, नन मेटल्समा इलेक्ट्रोन्स डिभोइड हुन्छ, त्यस्तो केसमा चाहिँ के हुन्छ त, त्यो इलेक्ट्रिसिटीले सप्लाई गरेको इलेक्ट्रोन त्यो मटेरियलले नै एब्जर्ब गर्छ, हैन? अब यसलाई पनि तिमीले म्याराथन केससँग जोड्न सकिन्छ हेर त. सो the speed of marathon runner depends on nature of road as well, isn't it? If you are running in very smooth road, then you can run very fast. But if you have to run through a ragged road, or what if you have to run through muddy road, can you run as fast? No, definitely no. ढुङ्गै ढुङ्गा भएको बग्रेलको बाटो या चाहिँ माटै माटो हिलो भएको बाटो, खोला छेउको बाटो दौडिनु पर्यो भने तिमी पिच रोडमा दौडेको जस्तै गरी फास्ट दौडिन सक्छौ होला त? सक्दैनौ नि, हैन? यो म्याराथन रनरको स्पिड बाटोमा पनि भर पर्छ नि, कस्तो बाटोमा दौडिरहेको छ त्यसमा भर पर्छ नि. त्यसरी नै यो इलेक्ट्रोनको स्पिड पनि मटेरियलको नेचरमा भर पर्छ है. सो द रेजिस्टेन्स अल्सो डिपेन्ड्स अन नेचर अफ मटेरियल. And last one is shape of wire. Okay, shape of wire. Once again we can correlate it to marathon runners. Your marathon runners, they have to run, yes, if the road is very straight. Case number 1, road is very straight. Case number 2, the road is too much curvy one. There are too many turns in the road. What happens? In which case the runners will run fast? Is it in case of straight road, or is it in case of roads with turning? Definitely, if there are turns, then they have to slow down to take the turn, isn't it? They have to slow down to take the turn, and before they can gain their full speed, if there is another turn, then they again have to slow down, isn't it? In this way, if there are too many turnings, then they cannot run with their full speed. If the road is totally straight, then they can run with full speed. Just like that, electrons or electricity can also move with full speed, with full energy, if they are running through straight wire. If electricity is flowing through straight wire, there will be less resistance. But if the electricity has to flow through coiled wire means there are continuous turn, isn't it? If they have to run through coiled wire, then there is very high resistance. Any confusion here? See, R is proportional to L, R is inversely proportional to L, A, R is proportional to T, and R depends on nature of material, and R depends on shape of wire. Okay, any confusion? Okay, if no, then today we will do only this much. In our next class, we will discuss further about resistance and resistivity, and we will also do the numericals. Until then, I would like to wrap my class here. Okay, thank you very much everyone.